Hi everyone, and welcome to section 7.3 Notes Key. Hopefully you viewed the 7.3 notes on shapes of distributions and histograms. You attempted problems examples 1, 2, 3, and 4, and now you can check your work with me. All right, so let's get started. Example 2 says, describe the shape of the box and whiskers plot and explain your reasoning. Decide what measure of center would be best for each. Well, remember that skew is where the tail trails. So since we have a tail extending to the right in this box and whisker plot, we would say this graph is skewed right. And since this graph is skewed, we would use the median or the mode as the appropriate measure of center because we know the mean is influenced by unique or out of the ordinary values. So the median or mode would represent the middle since the data is skewed. Okay. The next distribution doesn't seem to have a tail in either direction. Therefore, we would say that it is approximately symmetric. And for approximately symmetric distributions, you can use the mean, median, or mode as an appropriate measure of center. They should all be approximately the same in a symmetric distribution. All right, example 3, we're comparing distributions using their shape and appropriate measures of center. Now, when we compare, we want to make sure that we do talk about both distributions, not just list comparisons, facts about the one and then the other. We really do want to compare. So one thing that we can see here is that professional football players seem to have less career experience than company employees. And we can tell that because professional football players have a skewed right distribution where most of them have between 3 to 5 years experience, and company employees have a more symmetric distribution where most of those employees have between 9 to 14 years experience. So we can say that also football players have at most 20 years experience, and company employees have at most 23 years experience. And we can go into a lot of factors about why this is what it is, but it just makes sense that for career longevity, professional football players, we know, don't have the same career longevity as company employees might, just because of physical limitations and capabilities as you get older, right? Another thing we can point out is that there is a gap in the graph here. There are no professional football players that have between 15 to 17 years of experience, but we do not have a gap in the graph over here between 15 and 17 years experience. We actually have a quite high frequency of probably around 18. So all we want to really do is analyze the graphs using important vocab that we learned from the section and make sure that we make an argument that we can stand by and we can support with mathematical vocabulary and work and reasoning. All right, so example number 4, what you're looking at is you are looking to build a histogram. However, unlike on example number 1, you are given completely raw data. We don't have any table. We have no frequencies. We need to build our own frequency table so that we can turn it into a histogram. Now, part A tells you exactly how to do that. It says display the data in a histogram, and we're going to be using 7 intervals. So it tells me exactly how many intervals to use, 7, and it tells me exactly where to start and how wide they should be. So I'm going to show you what this looks like. We're going to set up a table here, and we're going to have 3 columns, one labeled interval, one labeled tally mark, and one labeled frequency. This is how we're going to set this up all the time so that we can make sure we collect the data in the most accurate and appropriate way. My first interval is 26 to 50. Now we know all intervals need to be of equal size, and I'm going to have 7 of them. So I'm going to make room for that. There's interval 1, 2, 3, 4, 5, 6, and 7 is down at the bottom. Okay, so here's how we can figure out how wide the intervals need to be. I can take my first interval 50 and subtract 26 and I get 24. This is how many values are going to lie within each interval. The next number falling in line after 50 would be 51. And 51 plus 24 is 75. So that is where that second interval is going to end, 51 to 75. And then we can kind of see a pattern. We're going to get 76 to 100. 101 to 125, 126 to 150, 151 to 175, and 176 to 200. Okay, now that we have our interval set up, what we're going to do is we are going to go ahead and place these data points in their appropriate interval. So what I mean by that is our first data point is 120. I'm going to place that here because 120 falls between 101 and 125. Let's keep going. 60 here, 150 here, 120 here, 30. Keep going. 60, 100. Take your time. 70, 100, 40, 80, 60, 50, stay organized, 200, 150, 40, 70, 80, 50, 175, 50, 30, 110, and lastly 100. Now I can go ahead and total up those tally marks to make my frequency table. My first column I have 7, my next column I have 5, 5, 3, 2, 1, and 1. Now I just built a frequency table from raw data, and now I know how to make a histogram. All right, my y-axis always on a histogram is going to be frequency, and my x-axis is going to be labeled in context, which would be ATM withdrawals. My frequency is going from 1 to 7, so I can go by ones on my axis. And I'm going to go in and I'm going to just make sure that I can equally space each bar with the class label appropriately in between each of those bars. And I am going to have to extend my graph just a little bit, but that's okay. We can do that. And then we're going to build our columns. So my first column, 26 through 50, I'm going to make sure the label is directly in the center of my bar, has a frequency of 7. My next column is 51 through 75, that has a frequency of 5. My next column is 76 to 100 with a frequency of 5. 101 to 125 with a frequency of 3. 126 to 150 with a frequency of 2. 151 to 175 with a frequency of 1. and 176 to 200 with a frequency of 1. Things you need to make sure that you always include with a histogram. Your y-axis starts at 0 and increases at an even scale. Your y-axis is labeled frequency. On your x-axis, you have an in-context label. Each column is an equal width, and each column has the name or label of the category centered in the middle of that column as shown. All right, let's move on. Part B says, which measure of center, not variation, we haven't learned that yet, would be best to represent the data? And the answer here would be either the median or the mode. Since the data is skewed right, either is correct for mathematical purposes, but for contextual purposes, I'm not really sure why we would care about the median number of ATM withdrawals. We would probably care about what type of withdrawals people make most, so the mode would make sense for the context. Part D says, or C actually, sorry, says the bank charges a fee for any ATM withdrawal less than $150. How would you interpret that? So basically, what we're saying is now anything less than $150 is now going to increase with a fee. So what we would expect is we would expect data values to increase or withdrawals to increase. And those data values would therefore, they would therefore be closer to the tails of the graph, and we would see something less skewed. We would see a distribution that is possibly more symmetric. Okay, you guys, I hope that you completed examples 2, 3, and 4 on your own and then viewed this video to see how well you have done. You have a practice 7.3 worksheet for homework tonight. Please, please, please either contact me via Remind if you need to schedule an appointment Wednesday for tutoring help. Also, I'll be available for you via virtual classroom link Thursday from 1:40 to 2:30 if you need help. Please come get help before it's too late. I'm always here for you, and you can pop in just for the slightest, tiniest question. Rather have you guys feel comfortable than get lost. I will see you Friday. Bye. Case